Hey everyone, so today we will be solving a Leetcode question number 36, which is valid Sudoku. So the problem statement is determine if a 9 by 9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. So here is the Sudoku board, right? It's a 9 by 9 board, basically 9 cells in each row and column, and the rules are each row must contain the digits 1 to 9 without repetition. Means from 1 to 9, since there are 9 cells, each digit should appear only once in the row, in each row. And then the second one is each column must contain the digits 1 to 9 without repetition. So when you go column wise from up to down here, you should have digits 1 to 9 appear, each digit appearing only once. Then the third one is each of the 9 3 by 3 sub boxes of the grid must contain the digits 1 to 9 without repetition. So we have divided this entire board into like 9 boxes here, right? So when you consider one box, there are 9 cells. So within this box, or each box also, each digit should appear only once. That is the third one. And then there are a few notes here, which is pretty much telling you that only this board doesn't need to be fully filled. It can be partially filled like this. And the question doesn't ask you to fill the empty cells. The question only asks you that it just needs to be validated, whether it's a good Sudoku board or not. That's all. And then they're giving an example here where they present the board in the terms of a 9 by 9 matrix. Yeah, you see double square bracket, so that's a 9 by 9 matrix. And then if it's an empty cell, right, like this one, it will be represented by a dot. These are the empty cells here, right? So that is pretty much the question. If you look at the pane on the right, it will just tell you, okay, this is the function, and the board is given to you as a character matrix, because actually they are not considering this as numbers, they are just considering this as characters. So it's a two-dimensional matrix which is a character type, and we have to return with true or false whether it's a valid board or not. Okay, so let's go towards the solution. So I've opened a board here. So I have marked the indexes here. So this is the index, the first index and the second index, right? So each cell, now this cell 5 is represented by 0 0, this 0 1 0 2 0 3, that way, right? The whole board. So yeah, let us go into the solution. So now if you look at it, like for example, if you get an array, right? If suppose they are given an array with some numbers, right? Suppose 4 2 7 and then 4, right? So in this case, how will you find out if each digit appears only once? You will have to go through each array, each like number, and then keep comparing it with the other numbers, right? So you take this number and then you compare it with this, and if you find the same number, that means okay, it's not a unique array, right? And another approach, a better approach, is to use a data structure called set, right? So in this, what we will do, we will add each element in this set, right? So for example, now first you will add 4, then you will add 2, then you will add 7. Now when you come to 4, it's a set, right? Set means every element should appear only once. That is the definition of a set. So when it tries to add 4, it will not do it. It will not add 4 to it, because that will violate the property of the set. So it will just ignore it and just put 4 to 7, right? But we can use that property to check whether we have seen this element in the past or not, right? So we just check, does this set contain 4? Yes, it contains. So then we don't go with it. So when you come to this particular row, it's the same thing we can do, right? We can add all these elements to the set as we see them, and if we get something duplicate, like suppose if this number was a 5, and we do this process, we can instantly tell, we have already seen 5, so then this is an invalid Sudoku, right? There we can stop and we can quit, right? So that is the approach we'll be using. Now the thing to note is we have to consider a row, column, and then box, right? So if you consider this element, suppose 5, right? This 5 we are taking, this 5 is appearing in this row, it's appearing in this column, and then it's appearing in this box, right? 3 different things. So how do we distinguish? If we use just one set, we cannot just put, so let's create a new set here. So this is a set, right? We cannot just use like one set, because when we are traveling the row way, we will put 5. Then we are traveling the column, again we will have to put 5, correct, in the same set. So that is kind of, it's not going to help. So we have to use a different approach, right? So what we can do is we can add some uniqueness to each element, right? So for example, when we are on the row, we can say that when you're adding it to the set, you just add like because we know the index of each row, right? This is 0, 1, 2, second row, third row, fourth row, fifth row, that way, right? So we can say that let's add R0, suppose, for example, and then we will add, like, suppose this one, if you consider 5, right? Now this is our set. Then we will add R0, and then we add 3, R0, and then 7, right? That way. Now when it comes to column, what we can do is we can add C0, and then we add 5. Now if you consider this column, right, we're considering this column here, this one. I didn't do it properly, but like example, no, it's not templates. I think it shapes this one, right? So when we consider this is the column, right? So we will be doing C05, then we will do C06, C08, C04, and C07, right? So this is the column we can store all the elements, all the cells. Now for the box, what can we do for the box? So for the box, so these are our boxes, right? this is one box, right? So when we come to a box, so we have to also find some index for the box, like how we found the index for this row, and then we found the index of this column, right? So that way we have to also find the index of this box. Now if you look at it carefully, you will see that this they are like a two-dimensional matrix within this, if you consider, right? So this box is one, this box is the second one, this was the third one, right? And same thing with here. So they can be considered as a 3 by 3 kind of a matrix here, right? So here this one index is 0 comma 1, this one is 0 comma 0, sorry, 0 comma 1, and then this one is 0 comma 2. And then when we come to this one considered as 1 comma 0, 1 comma 1, 1 comma 2, 2 comma 0, 2 comma 1, and 2 comma 2, right? This way we can split the boxes. Now so then when we see 5 here in the box, what we can do is we can add B for box, and then we can add 0 0 for the box index, and then we can add 5, right? Same way the next one, suppose we do 3, so we have B 0 0, this will remain the same because in the same box. Then we add 3, then we consider the next one, it is 6, so we put 0 0 and then 6 because this 6 is in this box, right? Then we consider this 9 now, same way, B 0 0 and 9, and so forth, right? So now for example, how do we get now, because this 5 is just in a normal 9 by 9 array, right? This is a 9 by 9, I mean in a matrix, right? So how this 5 actually in the main board, which is multi-dimensional, two-dimensional array, this 5 has the index of 0 comma 0, right? So we have to, okay, this may be not the right example, but say suppose for example let's consider 6 in this case, right? Now 6 index is 1 comma 0, right? But we have to prepend B00, right? So how do you do it? Now for example, also let's consider this box here, right? This box. So consider 8. Now 8 is actually, if you see here, 0 comma 3, right? 0 comma 3 is the actual index, 3 and then 0, right? So 0 comma 3. So but it needs to be belong to the box of 1 1 0, right? As we labeled here, 1 0, it has to translate to 1 comma 0, right? Actually no, sorry, this is 3 comma 0, this is 3 comma 0, right? So that way, how do we translate this to 1 0? Now let's take this example of 9 here. This 9 is having actual index of 8 comma 8, right? So this needs to be translated to the box of 2 2, right? So how do these translations can happen so that we can be successfully adding the right box index to the set, right? So what we do is, since if you see closely, we are dividing the rows into 3 sections: 1 2 and 3, right? So we can divide each index by 3, right? The actual index we can divide it by 3 to get the actual box index, right? So for example, let's try that approach on this 8, which is 3 comma 0, the real index. We need to translate to 1 0. Now we have 3. If you divide by 3, we get 1, correct? And then 0, we divide by 3, we get 0. So this 1 0 is right. We got it by doing this operation. Now 9 is another example. We can take example of 9 and then take 8, right? So we are taking 8 index divided by 3, and we are not doing the actual division, we are doing the rounded division, right? So you will not get 2 point something, you will get only 2. So we'll take 2, and then this one also same thing, 8 by 3, 2. So we are getting 2 2, right? So that is the actual box index which we want. So that is how we can translate it, right? So that way what we'll be doing is we'll be using only one big set, and we will add all these elements, row elements, column elements, box elements to the set. And if we find duplicates, instantly we can stop right there and return false, right? So that is the basic approach. Now we can write some pseudocode. So let me just scroll there down. So this is our function. Right. So can use this as a reference. Right. So let's say we're starting this way, right? Okay. So we have this. So now first thing what we will do is we will we'll have to take the set. So we'll create a set here. So we call it set of, now since we'll be adding things like, we need to add things like R0 3, right? So this is like a string, so we will create a set of string, and we will call it like just set equals new. I'll be using Java, so yeah, this is all Java code. We'll create a hash set, which is, this is the set is the interface and this is the actual implementation. So hash set this, right? Now we will iterate through the board. So for int I equals 0, actually let's use a different kind of a thing. Let's use r comma c, because r can be used for row and c can be used for column. So let's use that one. R equal to 0, r is less than 9, right? And because it's going to be a fixed 9x9 board, we're not going to get anything else because it's defined here that board length is always 9, so it's a fixed board, right? R++. Then we go for the column, so int c is equal to 0, c less than 9, c++. Okay, and then we start our logic here. So what we can do is we can first of all just check if it is empty cell or not, right? So what we can just say, if board of RC not equals to dot, then only you go towards the logic which will be building to, right? So what do we do now? We have to check for these, right? The elements look like this. So first let's do row, then we'll do column, and then we'll do the box. So let's start with the row. So if we can also take it in some variable actually, so we don't need to do it all the time. So we can take this and put it into a variable, correct? So right here we can say char of, say for example, like input, right? So we can say maybe we can just say D, right? Digit. So digit is equal to board of R, C, and then we can get rid of this, and you can just say, let's get rid of all this. We can just say if T is not equal to dot, and then only do this. And now we can say if D actually we have to go for the set. So if set contains row, so R, right, plus I is the row, so I mean R is the row, so we'll just say have to plus R and then plus D, correct? So this will translate to, for example, R0, and then if the actual character is 5, it will do R0 and 5, because R will be 0 from here. So that way we can check for the row type. Then if it contains or, right, so if set dot contains, same thing, set dot contains, you'll go with C here. So C plus D, correct? Or set dot contains, this is the tricky one, so you have to be careful and implement it correctly. Here you have to put p plus r by 3 and plus c by 3. By the way, this plus is a concatenation. It's not an it's not a mathematical operation. It's a concatenation. So here, for this example, this whole thing will give you something like b, say like 0, 0, and then the actual digit 5. Right, like this. This is the result of this operation. So now, if it contains any of this, that means what I have to do? That means it's not unique, right? Because we have found it already in the set. So we return false and quit right here. So we return false. Right, so this quits here. And then if I mean, you can do else here. So else, let me scroll up. Else what do we do? Oh. Else we have not found that particular combination. Like, for example, we have not found R05 or these elements already, so we have to add it, right? This is the way. This is the in the start of your processing the board, the first element will be, it will come to an else because it won't be found in the set, right? So here you will add it to the set. So add, and you add the same in the same format, right? Which what we use. So plus r plus d, and then this repeats, right? Same thing you will add for column. So c plus d, and then for the box we add b plus r by 3 plus c by 3 plus d. Okay, and then at the end we can zoom out a little bit here and here. So once we are actually done with this, if nothing else, right? So we can close this, and once we close this one, we also close the for loop. Okay. And then for the main function, before ending the main function, we say return true, because if you process the entire board here, after this for loop both are done, then we have processed the entire board, and then we have never reached this condition, right? That means what? That means we are valid and we return true. And that's pretty much it. It's very actually it's a very straightforward implementation. The only thing you need to remember that is that you need to use a set, and you need to design the set in such a way that it can support rows, columns and boxes. Alright, thank you, hope this helps.